Section 7.1, sine, cosine, and tangent graphs. The first thing you're going to want to do is to do this activity. So by using the unit circle to complete the t-tables for each function, you should get through this pretty quickly. You're going to plot the points on the from the t-tables to the coordinate planes that are below. Now, again, you're just using your unit circle. So for like the sine of x is 0, so the sine of 0 is 0 here. The sine of pi over 6 we know would be equal to 1/2. The sine of pi over 4 is root 2 over 2. The sine of pi over 3 would be root 3 over 2, and the sine of pi over 2 is equal to 1. So you guys need to finish those for each of the values, and then you're going to plot those values down here. So 0, 0 for sine, then you have pi over 6, 1/2, pi over 4, root 2 over 2, which is, remember, is a decimal 0.707, and then root pi over 3, root 3 over 2, pi over 2, 1, and then you're going to make a smooth curve and complete the graph. So do that for this and then come back. So you might want to push pause and do that if you haven't already. So after you graph all these and put your chart down, this is the first graph that you'll get. And notice that at the very bottom of your paper, it said to, in a different color, to complete the graph for coterminal angles up to 4 pi. So the way that I did that, I knew 13 pi over 6 was coterminal with pi over 6, so that's why I got a value of 1/2. 9 pi over 4 is coterminal with pi over 4, which is where you get root 2 over 2. 7 pi over 3 is coterminal with pi over 3, that's why we get this value here. 5 pi over 2 is coterminal with pi over 2, and then you just keep going down your circle. So notice that in this case, the first wavelength and the second wavelength are the same. Now I can also do this going in the negative direction on my graph, which we'll talk about in a little bit. So if you look at this graph here, a couple of things that I want to talk about. Notice that here we have a maximum value and here we have a minimum value. So this maximum value is at pi over 2 comma 1, and the minimum value here is at pi over 2 comma -1. So those are two values that you're going to look at. Now, another thing that we will be talking about is what's called the amplitude of these graphs, and the amplitude is half the distance between the maximum and minimum values. So half the distance between the maximum and minimum would be 1. So because 1 plus 1 is 2, and 2 divided by 2 is 1. So then in this case, this right here is what we call an amplitude. And if you notice that my x-axis are my angles, and for this I could keep on going. I can keep going around my circle, and I could add more to my graph going this way, or like I said before, I can go negative on my graph. That means that the domain of your graph, you notice, is going to be all real numbers. However, this is what we were talking about before, the range of your graph oscillates back and forth in between 1 and -1. So since it goes back and forth between 1 and -1, the range of our graph is going to be bracket 1 to, or bracket -1 to 1 bracket. And we'll talk about that again a little bit later. So then if you look at your cosine graph, now notice your cosine graph is very similar to your sine graph. The only difference between the two is that it's shifted over, and we'll talk about shifts of graphs in a little bit later. But if you look at this cosine graph, notice that for this, it starts at 1 instead of starting at 0, 0, and it goes down instead of going up first. And now notice for this graph here, we have from here to here is where our graph is going to start repeating itself. So this is where our graph stops on this one, and over here for sine, our graph stopped right here. So from here all the way to here, this is one wave. And same thing that I just did here, we have one wave. And then this next part from here, oops, I'm sorry, this should have been going up to here. I didn't realize I did that. So that should have been here. So this is one wave from 0 to 2 pi. And that makes sense because that's how it takes us to go once around our circle. So then from here over to here, that would be the second wave, and so on and so forth. And because these waves are going to continue, these graphs are what we call periodic in nature. So let's go ahead and go to our notes. So recall before we do this that even functions are have symmetry with respect to the y-axis. And algebraically, remember that we did f of negative x would be equal to negative of the function. And that's because remember that, or sorry, we were doing even. So for this, just f of negative x equals f of x because we have y-axis symmetry. So then for odd functions, remember that the symmetry is with respect to the origin. And so this is f of negative x equals the negative of the function because you would make, if you have xy in your graph, you have negative xy on your graph. And for even functions, if you have xy on your graph, then you have negative x comma y on your graph. Now, when the terminal side of theta is rotated counterclockwise about the origin, the values of x and y associated with the point P will change. For each value of theta, there's exactly one corresponding value for x. We have this set of ordered pairs, and I'm going to talk about that in a second, that gives us the cosine graph, and then one that gives us the sine graph. Now remember, we talked about the unit circle before, and in this case, this is the angle theta for this picture that we have. And remember, we talked about the unit circle means you have a radius of 1, and then we said that this right here was our y, and this down here was our x, and so we got, in this case, opposites over hypotenuse, and that's why we got y is equal to the sine of theta, and x was equal to the cosine of theta. So we have the point, then we said p of x comma y is equal to cosine theta comma sine theta. Now, when we're graphing this, we don't use that. We use the fact that we know y is equal to the sine of theta. So your coordinate ordered pairs that you're going to use for this are going to be your angle, comma, the sine of that angle gives you your y value. And so for cosine, it's x equals the cosine of theta. So then your coordinate ordered pair when we're graphing these is going to be your angle, comma, the cosine of theta. So that's what goes up here. So we have theta, comma, cosine, theta for cosine, and theta, comma, sine theta for sine. And when we're graphing these, your calculator needs to be in radian mode. We'll talk about graphing these and looking at the graphs a little bit later. So for your homework, you're going to be graphing all these by hand, which is why I'm going to do all this by hand. Now, let's go ahead and talk about what we just talked about a second ago. We can rotate around the circle an infinite many times, either in the positive direction or the negative direction. Therefore, the domain of sine and both cosine is going to always be negative infinity to infinity, so all real numbers. These values of sine and cosine also range or oscillates from -1 to 1, because the highest and lowest points we can go on our graph are in between those values. Now for this, if we add 2 pi, which remember is 360 degrees, to each value of t in the interval from 0 to 2 pi, this completes a second revolution around the unit circle, and then we can keep on doing it, and again in the negative direction. So functions that behave in such repetitive or cyclic manner are called periodic. The sine and cosine functions are periodic functions with a period of, so then something that has a period is how long does it take us to go around our circle. So in this case, 2 pi radians to go around once before our graph starts to repeat. So the length of each cycle before it starts to repeat is the period of the function, and again, that's the horizontal distance. So it's the horizontal distance it takes to make one wave before repeating. And so because of that, we know that one wave equals one cycle, which is the period of our graph. So those are important to know. So in this next thing, it says how many periods are shown in the graph. So this is y equals the sine of x. And how did I know it was y equals the sine of x? Because if you look right here, we have 0, 0 as an intercept. Sine always starts at 0, 0, whereas cosine starts at 1. So if I want to figure out how many periods are shown or how many cycles are shown or how many waves are shown, it means the same thing. I'm going to look at one wavelength. So from here to here, remember we said that was our parent graph. So for sine. So because of that, I know from there to there, that would be one cycle and then, or one wave. And then before, when it starts to repeat, would be right here. So at this point on my graph is where I'm starting to repeat. So I know that there are 2 periods shown in the graph for this graph that we have at the right. So let's talk more specifically about the graph of sine. So to sketch the basic graph of sine by hand, it helps to note 5 key points in one period. The key points are the intercepts, and the maximum and minimum points. Oops. So those are going to be the key values. So it's the intercept, the maximum, and minimum points of your graph. So to get the key points, you are going to divide the period of the function into 4 equal parts. So this is very important. Why would we divide it into 4 equal points? Well, let's look at our graph. So we already graphed in the other one. So on your page, you have 0, 0. Pi over 2 is 1, so that's a maximum. At pi, we have 0. At 3 pi over 2, we have -1. And at 2 pi, we also have 0. So notice those are the intercepts of my graph, and also they are the maximum and minimum values. So if you think about your unit circle, well, where do those occur? Well, 0 is here, and then we have pi over 2, pi, 3 pi over 2, and back around. And notice that it's divided into 4 equal parts, so it's every fourth of my circle. So it's nice that we can get the key points just by dividing the period of your graph by 4. And our period of a graph is going to end up changing, but we're not going to talk about that till a little bit later on. So we already talked about the domain. It's -infinity to infinity. The range we said was -1 to 1. And the period for sine and cosine for right now is 2 pi. So then the key points again are you're going to take your period and divide it by 2 pi, or divide it by 4 for your key points. So in this case, this just tells us what our key points are going by on our graph, and I get pi over 2. So that means every pi over 2 starting from 0, I'm going to get a key point on my graph, because we don't always, when we're graphing these, want to graph each individual value like we did. Let's go back to the other graph. You don't always have to graph each of these individual points right here, here, and here. Those values, they're still important, but we don't really need them when we're graphing. We just really need our intercepts and our max and min to kind of get the idea or shape of our graph. So that's what we're going to be using when we are graphing these. So I know from my table, I would start with x, and this would be the sine of x. So if I wanted to graph this, since sine starts at 0, so I would start at 0, and then I'm going to count by my key points to get my table. So 0 plus pi over 2 is 1 pi over 2, plus another pi over 2, so that would be 2 pi over 2, which is just pi, and then we have 3 pi over 2, and then 4 pi over 2, which is 2 pi. Those are the key points. So you always take that and add it from wherever you're starting, so add from 0. And that's nice because it gives me those key values on my graph that are the only ones that I'm going to be graphing. So the sine of 0 is 0. The sine of pi over 2 is 1, 0, -1, and 0. So that's why I have those on my graph. Now, remember that these values are going to keep going around your circle. So I'm at 2 pi right here. So if I add another pi, which would be 5 pi over 2, now I'm at 1. If I go to another pi, which would be right here, which is 3 pi, I would be at 0. And if I go down here, to another 3 pi over 2, or coterminal to 3 pi over 2 is 7 pi over 2, I would be down here and back around again to 4 pi. So I went all the way around my circle once, and then I went all the way around it again. And notice that those help me make the shape of my graph. Now I can also go in the negative direction on my graph. So if I start here at 2 pi, notice if I go the negative direction, I would negative pi over 2, which is right here at negative 1. And then if I did negative pi, I would be at 0. Negative 3 pi over 2, which would be up here, would be at 1. And then back around would be at 0. So I can go in the negative direction on my graph. So if you were looking at these, I can tell that I have 3 periods shown, so 3 cycles or 3 waves are shown on this graph. And the one that's in the middle, of course, is our parent function. So this is the parent graph. From here to here is the parent. So the sine graph has symmetry with respect to the origin, which makes it an odd function. So since it's an odd function, then I know that the sine of negative t, so the sine of a negative angle, is going to be equal to the negative of the sine of t. And just for an example of that, if I do the sine of negative pi over 4, it should be equal to the negative sine of pi over 4. So you can use your unit circle to kind of look at that. So the sine of pi over 4, negative, I know, is equal to negative root 2 over 2, because I'm down here in my unit circle. And the sine of pi over 4, sorry, I should say right here, because it's negative pi over 4. So I'm in the negative region is what I meant to say. So then if I do pi over 4, it would be right here at positive root 2 over 2, but that negative in front means we have negative root 2 over 2, and those are equal. So we'll do more of that, and we'll talk about these two right here in class. So let's go ahead and just skip that for now, and let's go to the graph of cosine. So the graph of cosine is similar to the graph of sine. For the graph of cosine, I know the domain is still negative infinity to infinity. The range is from bracket -1 to 1. The period is still 2 pi, what it takes to go once around my circle or complete one wave. Notice that the difference for cosine is that we start at 1, go down, and then up. So this would be my parent graph. So your key points, remember, you take your period divided by 4. So in this case, 2 pi over 4 is equal to pi over 4. So I know every pi over 4 I'm getting an x-intercept, or I'm getting a maximum value or a minimum value. So same thing, this would be x. And now we have the cosine of x. So I start at 0. So 0, 1 pi over 4, and then 2 pi over 4. 3 pi over 4, and 4 pi over 4 gives me my values. And it's easy to do right now, but like I said, those values will be changing when we do transformations. So the cosine of 0 is 1. The cosine of pi over 4 is 0. The cosine of pi is -1, and then 0 and 1. And again, you can get those values from a unit circle. So now if I keep going around my circle, 5 pi over 2 would be at 0. 3 pi would be at -1, because I know it's coterminal with pi. 7 pi over 2 is coterminal with 3 pi over 2, so we're at 0. And 4 pi is coterminal with 2 pi, which is at 1. So my graph goes this way, and of course my graph is going to keep on repeating. So then I can go backwards. So I know negative pi over 2 is coterminal with 3 pi over 2, and then negative pi would be down here at -1, 0, and then 1. So again, I'm just repeating my coterminal angles. And of course, my graph would continue. So I have 3 cycles shown right here. We know that cosine has symmetry with respect to the y-axis. So if I fold it in half on my y-axis, notice I end up with the same thing. So that makes it an even function. So for this, I know that the cosine of negative x is going to be equal to the cosine of x. And I can show that with some number. So if I do the cosine of negative pi over 4, it should be equal to the cosine of pi over 4. So negative pi over 4 cosine I know is equal to root 2 over 2. And then the cosine of pi over 4 is also equal to root 2 over 2. So that just shows that they are equal and it works. So that's for the cosine function. So let's go ahead and go to the next page. It says how many cycles or periods are shown in this graph. So if you want to tell how many cycles or periods are shown, you have to figure out when it's going to start repeating. So this looks like a sine or a cosine graph. I would say it's a cosine graph because it starts here, not at 0, 0. So before it starts repeating from here to here is when it looks like it's going to start repeating. So that would be 1. Then you have another one. Whoops. And then you notice you have another one right here. And then we can go backwards. So if you look, you have, and I guess you should have done that in a different color. 1, 2, 3, 4, 5. So 5 cycles are shown in this graph. So the next thing we would do in class is we'll do these two things. We'll talk about stating all the values. So let's lastly look at the graph of tangent. So for the graph of tangent, recall that from the unit circle, tangent is your y over x, which is really your sine theta over cosine theta. So that means that tangent is undefined when your cosine of theta is equal to 0. So because of that, remember when things are 0 in your denominator, that means you have asymptotes. So where do these asymptotes appear? Well, they appear at wherever cosine of theta is equal to 0. So where is the cosine of theta equal to 0? We can go back to our unit circle. So where's the cosine 0? We know that cosine is 0 at pi over 2, and then it's also 0 at 3 pi over 2. And I could keep going around my circle. So if we start at pi over 2, I get 3 pi over 2, which is pi halfway around my circle. And then if I go back up to pi over 2, I've added another pi to my equation. So for this, oops, I know that at first it started at pi over 2. Then we went to 3 pi over 2. I can also go backwards and get negative pi over 2 or negative 3 pi over 2, and I keep on adding values. But remember, this continues on and on because I can go around my circle infinite many times forward or backwards, or I should say clockwise or counterclockwise. That means to get all of the values, you start at the lowest one that you have, which is positive, so pi over 2. So pi over 2 plus, and then notice that the difference in between each of these is pi. So plus pi times n, where n equals an integer. And I would always add that n equals an integer. We'll talk about the domain in a little bit because it's not all real numbers because these are values that make it undefined. So it's all real numbers except for those values, which we'll talk about a little bit later. For this, the graphs must contain the dotted asymptote lines because of this, and the asymptote lines will move if the function contains a, well, how did those move if your function contains a horizontal shift, stretch, or shrink? And for this, let's go ahead and plot these on our graph. So on my graph, the period is a little bit different, which we'll look at in a second, but I'm going to tell you right now that the period is pi. So the period for tangent is different than sine and cosine. So your key points, remember, your period divided by 4. So in this case, pi over 4 is going to give me my values. So I'm going to do pi over 4 on my graph. So we have pi over 4, and if I had another pi over 4, that would be 2 pi over 4 or pi over 2. Then we have 3 pi over 4, and then 4 pi over 4, and then 5 pi over 4, and I'm going to do one more to go to 6 pi over 4, which is 3 pi over 2. And then I'm going to do negative, so negative pi over 4, negative 3 pi over 4, negative pi, negative, oops, did I miss one? I did, I missed pi over 2. Negative pi over 2, negative 3 pi over 4, negative pi, and negative 5 pi over 4. So let's go ahead and put our vertical asymptotes in. So at pi over 2, cosine is 0. And at 3 pi over 2, we said it was the next one. And then we also said we can go in the negative direction. So at negative pi over 2, and I guess I should add negative 3 pi over 2, which would be right here. Now for these, when you're graphing them, you always have to label your x-axis. I want to see every single mark labeled so that I know that you know how to graph these. So now we have to think about pi over 4, negative pi over 4, and 0 for tangent values. So if I look at my unit circle, remember tangent is sine over cosine. So tangent right here is 0. I know that the tangent of pi over 4 is 1. At negative pi over 4, it's negative 1. So I'm going to use those to help me graph. So for my graph here, tangent of 0, 0, pi over 4 would be 1. Negative pi over 4 is negative 1. So I know that part of my graph. How does the rest of it go? Well, think about your parent graphs for sine and cosine. So sine starts like this, and then cosine parent graph is always going to look something like this. So right here we have pi over 2 on this graph, and this is pi over 2 here. So if it's sine over cosine, well, sine at pi over 2 is 1 over cosine. Notice that the value is getting closer and closer to 0. So 1 over a small, oops, so 1 over a small number is equal to a large number. So that means that my graph is going to go up this way. Remember, we don't touch our vertical asymptotes or cross over them. So if I go the opposite way, I would have 1 over a very small negative number, which means I have a very large negative number. So my graph is going to go this way. So this is my tangent graph. Then if I look at pi, the tangent of pi is 0. The tangent of 5 pi over 4 is 1. Tangent of 3 pi over 4 is negative 1, which would be here. And notice that my graph would then go up this way and down. And then at negative pi, 0. At 3 pi over 4, I have 1. At negative 5 pi over 4, I have negative 1. And my graph goes up this way. So if you look at this, this one's different than sine and cosine. Notice that my graph starts repeating in between my asymptotes. So from here to here, this is my parent graph for tangent. So the parent graph is different, and notice it had some negative values and some positive values. So when I'm doing the parent graph of tangent, I usually put 0 in the middle, and then I count with the key point. So this would be pi over 4. This is going to be pi over 2, negative pi over 4, and negative pi over 2. So tangent here is undefined, negative 1, 0, 1, and then undefined again. That's the values that I used for my parent graph of tangent. So notice for this, tangent is an odd function with symmetry with respect to the origin. And notice that one complete cycle goes in between negative pi over 2 and pi over 2. And notice that I didn't put that in brackets. I'm using parentheses because we have those vertical asymptotes on our graphs at those places. So for our domain we can plug anything in except for where we have these asymptotes. So let's go back up to the domain of tangent. So we start with our first positive asymptote, which is right here. And notice that the distance when we start repeating in between for our graphs is pi. That's why the period of our function for tangent is pi. It's different than sine and cosine. So because of that, I know that the domain's all real numbers except, so negative infinity to infinity, But in this case, I'm going to use theta because I use theta up there. Theta cannot be equal to, well, where is it first an asymptote at? Pi over 2 plus every pi times n, where n is equal to an integer. That gives me my vertical asymptotes at each one of those. So for this, make sure you have all this written down, and then we're going to talk more in class about the tangent graph, and we'll also talk more about sine and cosine. And as I said, we will also, when we're done with that, we will fill in these other questions that we didn't get to, and we'll talk about that a little bit more. But make sure you have all the rest of this for class.